So what we're going to do for each of these, they say determine the amplitude. We're also going to graph them. So we're going to look at what does the graph of 2/3 sine x look like. Have to think about transformations. What does that 2/3 do? It's going to do a vertical stretch or compression. So our whole graph is going to get compressed by 2/3. So we have to imagine, we know what our parent graph looks like. We know that sine of x looks like this. We could split it into our 4 sections like we did before. And now we're going to have to multiply all of the y coordinates by 2/3. What is that graph going to look like? Well, it's actually not too bad to graph, because our graph normally had a maximum right there at pi over 2 comma 1. But when you multiply that by 2/3, it's now going to have a maximum. If we split this up into our 4 sections and label them, it's now going to have a maximum at 2/3. And it's going to affect our minimum as well. Instead of being at -1, it's now going to have a minimum at -2/3. The rest of our graph has the same shape as it has before, because multiplying by 2/3 will not affect all of our zeros, all of our x-intercepts. So our graph has been squished a little bit. If I would have drawn these two on the same graph, the 2/3 graph would look like that, because it's been squished towards the x-axis. What's the amplitude of this one then? 2/3. For part B, again, we know what our cos graph looks like. 4 equal sections. Our cos graph looks like that. Now we want to graph y equals -4 cos graph. -4 cos x. What does that -4 do? It's going to flip it over the x-axis. You're going to multiply your y values by -1. You're also going to multiply your y values by 4. So instead of going from 1 and -1, it's now going to go all the way up to 4, all the way down to -4. And a cos graph normally starts at a maximum, but when you multiply that by the -4, it's going to get flipped down, and it's going to start at a minimum. We split our graph up into those 4 sections again. Pi, pi over 2, 2 pi, and 3 pi over 2. Our x-intercepts aren't going to get changed when we multiply y by -4. So these 2 points aren't going to change. At pi, it was -1, but now it's going to get multiplied by -4. And this is our graph of y equals -4 cos x. What's the amplitude here? It's equal to 4. So whatever number is in front of sine or cos will always equal your amplitude. Except this one has a negative. We always call our amplitude a positive number. So we'll never say the amplitude is -4, because the amplitude is the distance from the maximum to the middle, to your sinusoidal axis. And so that's going to equal 4, not -4. Questions you can do for this one are 3a and b. 4, 5, and 9.